Hey friends, Miss Paraso here. So I wanted to just help you along if you're creating your cheat sheet and just some tips and pointers for when you're studying for math, because math is its own unique thing. It's more about process and how to apply things. So we're going to take a look at we learned 3 different things this geometry unit, well, 3 different topics. All right, so I'm going to kind of summarize each part and kind of think about that, and feel free to go back in your notes, add anything that you might feel is, usable information for you. All right, but we're going to go ahead. So we had angle relationships, and then we had Pythagorean theorem, and we also had volume. Okay, so angle relationships, that was back towards the beginning, so it's been a hot minute. I would encourage you to go back to your vocabulary. So let's just see what that looked like. All right, this was where we went to the Math is Fun website and we defined it. And this is all of your vocabulary that you need. And I'm pretty sure I also gave you, let me just take a look here. I think I had a Quizlet as well that I gave you. I'll have to go back and look for that, but that had all of the vocabulary for that too. So anywho, so vocabulary is the huge thing. So for me, pick which ones you don't feel comfortable with, right? So maybe you have brain fart moments and you're like, okay, what is complementary? And maybe you want to draw a picture of complementary. And complementary angles are 2 angles that add up to 90, right? So angle 1 plus angle 2 equals 90, right? Maybe we're going to say that this means it's complementary. We want to have that word on there. So if we see it on a quiz or a test, we go, what was complementary? And we can see 2 angles that have a sum of 90 degrees, right? And they don't have to be next to each other. But again, our notes are meant to be short, sweet, and to the point. Just something that we can really quickly look at. If we write out a whole bunch of stuff, it becomes overwhelming and actually is counterintuitive. Like it doesn't help us as easily. Again, that's really your call on that. So, and then maybe we also have in here, right, when we know a straight angle is 180, so maybe we have these angles here, that this angle right here and this angle right here, they come together. They're technically a linear pair, okay? Let's do it in blue. Angle 1 and angle 2, right? But supplementary is they come together to form a straight line. It can be a linear pair. All right, linear pair means they join together. It's like puzzle pieces. But supplementary just means that the 2 angles add up to 180. They don't have to be next to each other. Okay, so those are some of the ones that were kind of reviewed from last year. We also had ones like this where we had vertical. And the idea with vertical was that we have this one line, and it's the angles formed by 2 intersecting lines there. And notice that the angles that are across from each other, so they share a vertex, and notice it's made up of, so you can see my cursor here, this pink and this green line, right? So they share a vertex and they are equal in value. So let's call this angle 1 and angle 2. They're vertical, right? We can also have 3 and 4 as well. So angle 1 is equal to angle 2. Angle 3 is equal to angle 4. So if we see those visual relationships, we know how to identify them. And if we also see the word, we now also know how to identify them, okay? Some other angle relationships we explored were those with the parallel lines. And this was very much vocabulary based, okay? And so if we had a pair of parallel lines, okay, whichever direction they're going, all right, we'll just call this line A, line B, and this is line, let's just call it W. All right, and so when that crosses it, that's that transversal, all right, we get these angles here, 1, 2, 3, 4, 5, 6, 7, 8. All right, and so there was a lot of vocabulary that kind of went with this. And so on your cheat sheet, you might want to give some examples with the different vocabulary. So for example, I might say we had alternate interior, angles. And we also had alternate exterior. All right, so I'm just going to list out all of the different, we talked about corresponding. This helps if I spell it right. Corresponding angles. So alternate interior, alternate exterior, corresponding. And then we just talked about, we had alternate consecutive, but that one we didn't really need to know too much. But the thing is with all of these is that they were equal in value, okay? So if we identify them as this relationship, and so essentially what we want to do is if I gave you one angle, how did we identify all of the equal ones? So a good rule of thumb is basically if there are a pair of parallel lines and only one transversal, if all the big angles are going to be equal to each other and all the small angles are going to be equal to each other. Again, that's in your most basic diagram of just one set of parallel lines and one transversal. So for example here, 1 and 4, I know those are equal because they're vertical, all right? But then I can kind of slide this whole idea down. Let's see, let's do this in like a green, right? This angle right here, I can click on that. Oh, it's not going to let me. Hold on. Because I did it in 2 strokes. Let's do that. All right, there's that angle there. I can click it and I can drag it down and I can see it's exactly the same as 5, right? So because it's 1 and 5 are the same, I know they're going to see, well, 5 and 8 are vertical. So essentially what I've just done is I've identified all of the ones that are equal in value. Now let's go through and name them. Which ones are my alternate interior? Well, alternate means opposite. Interior means inside the parallel lines. So that's going to be angle 4 and angle 5, right? Angle 4 and angle 5 are equal to each other. They are alternate interior, okay? And my alternate exterior would be angle 1 and angle 8. That's a pair of alternate exterior angles, okay? They're on opposite sides, but they are outside. They are outside of the parallel lines. And then we have our corresponding angles, which they are in the same corner. So corresponding, same corner on the same side. So that goes back to this idea here where I had that line and I just went right there and no turning it around, just sliding it on down and on the same side of that transversal. So here, angle 1 corresponds to angle 5. Now, there's more than those, okay? And so if we kind of go through here, I told you to choose 2 different colors. So this means 2, 3, 6, and 7 are all equal in value. Okay, so we have another set of alternate interior angles. We had 4 and 5, okay? Well, now we also have angles 3 and 6, okay? Those are equal in value. They're on alternate sides of the transversal and they're inside. Another set of alternate exterior, well, that's the other 2 and 7, the other 2 that are on the outside. We have angle 2 is equal to angle 7, because of that relationship. Now, we actually had more corners and stuff. We're going to have more information here. So if I go back to like the ones that I've highlighted in green, I've got angle 3 is equal to angle 7 because they're corresponding. And another set is angle 2 is equal to angle 6. Those are also corresponding. And if I go back to the yellow ones, I had 1 and 5. I already took care of those 2. So now I'm going to do 4 and 8. Okay, so there's a lot of different relationships. You could also talk about how angle 1 and angle 2 are a linear pair. We can see that any yellow and green are always going to add up to 180. So those are little notes that you might want to add, especially if you're going to do some color coding that can help you create those shortcuts. All right, the other thing for angle relationships that we talked about was we talked about triangles. Okay, and how we had a triangle, the angles all add up. That's the triangle sum theorem, that all angles add up to 180. All angles add to 180 degrees, and more specifically the inside angle. So let's call this angle A, B, and C. So angle A plus angle B plus angle C equal 180. All right. But then this year we added on to that. We said, hey, well, if we were to extend this out, okay, and we label this outside angle, angle D. Well, this also had this relationship, and it was called the exterior angle. And I'm not going to go through, you can go back to the past videos to go see in the proof before it. All right, but we know that the exterior angle, right, is going to equal the sum of the two insides. So the best way with drawing this diagram is just to show we got the two inside angles that are not next to the outside one, okay, is going to equal angle D. All right, and that's essentially what it's saying. So you have a couple of different ways that you could take a look at those angle relationships. So that pretty much covers our angle relationship section. And that was a lot. I mean, there was a lot of vocabulary. I highly encourage you to go back and take a look at that. And if you're interested in more cheat sheet notes, go ahead and tune into the next video where I will cover Pythagorean theorem and our volume.